Hello and welcome to the presentation. Today we're going to be going over an introduction to Git and GitHub. And here are the topics for today. Alrighty, first of all, what is Git? So Git is something that is called a version control software. And what does a version control software do? Well, it tracks file and folder structure changes. So pretty much what that means is that, let's say you're writing your code and you make a change to your code. This piece of software can keep track of the changes of your code as you write your full program. And with that, you're also able to revert back to old code. So Git specifically was created by Linus Torvalds, and you may have heard of this person because this person also was the original creator of Linux, of the Linux kernel. So why are we using this? So we're using it because it is open source and it is an industry standard. It's easy to view past changes and to revert to old code. And you have the ability to work on new code without overwriting old code. And so also with the way that Git was created, it is great for collaboration on a team. So in the bottom left here, you can see the Git logo. And the bottom right, you can see Git being used in the terminal. All right, let's talk about what is GitHub. So GitHub is a cloud-based service that interfaces with Git. And GitHub offers remote storage, better tools for collaboration, and a visual interface. And so in the center here, you can see an image of a repository in GitHub. And this is a project that I had made. And you could see different messages about the types of changes that have been made and the files here as well. All right, let's talk about Git GUIs. So I previously said that you can access Git in the terminal, but also there are some tools that allow you to interface with Git through a GUI. So a few examples. We have Visual Studio Code, which has a very nice extension that allows you to interface with Git. We also have, GitHub Desktop, which is also a very nice program. And we also have Source Tree right here, which I've also used. And let me actually go to these programs really quick to show you some of the features. So, for example, so this is the icon for the extension for Git for Visual Studio Code. And when I click on it, it opens an area for source control. And right here, you can see the changes of my code that I have not saved yet to Git. So if I click on this, you can see that there are changes between the past file and the new file. You can see I've added a comment here, a few comments and stuff, but I've also removed some blank lines you can see in red on this side. Also, let's go to GitHub Desktop. So this is the exact same repository that we're looking at. And again, you can see the file changes. You can see a history of changes as well. And in red are things that have been removed, green, things that have been added. And then I will leave source tree to a later date, but pretty much it's another way of visualizing data from Git and also interacting with Git. Alrighty, so let's go through some common Git terminology. So first of all, Git repository. So a Git repository is a name for a Git project. So you can pretty much just imagine a project folder that contains all the folders for your project, and inside of that folder, anything that changes inside that folder is recognized by Git and is able to be saved with a version history. Next, we have branch. So branch is pretty much a snapshot of your changes isolated from the main branch and other branches. So you can imagine the main branch like a tree, where you have the trunk of the tree, and a branch off from that would be isolated from the main branch. So let's talk about what the main branch is. So the main branch is a branch that should only contain the most stable code, and the pretty much when you go to use Git, you're going to want to branch out, make changes and stuff, and then you'll be merging that branch back into the main branch with working and functional code. So, and then lastly, what is a commit? So a commit is a saved state of a branch on the Git tree. So each of these circles here, these nodes, are commits. And pretty much when you make a series of changes, you would commit those changes to the tree, and that would be a saved version of your file and folder structure on the tree. All right, let's talk about what is a local repository. So a local Git repository is one that resides on your local computer. And a remote repository is a repository that resides on a different computer. And this can be on your local network, for example, or it can also be on the internet. So for example, we were talking about GitHub previously. This would be an example of a remote repository. And pretty much what you would do is using Git, you're able to pretty much download a clone of the code, make changes, and then upload your changes to the remote repository. So you'd be downloading changes. So if you're on like a team project, you'd be downloading changes from the remote, and then you make changes so that you can update your local repository. Then you make changes and upload those changes to the remote repository so that other people can access the up-to-date code. So common Git functions. So first of all, clone. So we just talked about that cloning is pretty much downloading a copy of a repository. And so this command can be used on your local computer, but it's usually used when you want to make a copy of a remote repository. And then we have fetch, which is a way to sync information from a remote repository to your local repository. So let's say one of your team members made some type of change to the remote repository, you'd be able to call a fetch command and update your local repository with that new information. And then pull. So pull syncs changes from a remote repository, or it syncs changes from a remote branch to your local branch. So the difference between pull and fetch is that fetch, for example, let's say someone on your team has created a few new branches. You would not get that information if you just called the pull commands. You'd only get that information when you call the fetch command. The pull command is for an individual branch, the changes on that branch, while fetch is for the repository as a whole. And then commit. So commit, once again, is saving a snapshot of your current code changes locally, and that'd be saved on a branch. And then we have push, which after you commit, you're going to want to publish the changes to your remote repository, which is called a push. And that is uploading the changes to the remote repository. And finally, we have merge, which is merging changes from one branch to another. All right, let's continue. So, what is a pull request? So a pull request is a request to merge changes into another branch. And because it's a request, it allows for code reviews and discussions about the code to be merged. So there's also a in Git, the merge command actually merges changes right away, but sometimes you don't want that, because sometimes you want the code to be reviewed by another person before the changes take effect in your main branch or your develop branch. So GitHub has a feature called a pull request, which gives the ability for discussion about the code changes. And in the bottom left, you can see an example right here where you can see changes down here, and these are all commits. And then the branch right here is work in progress, WIP. And this request is a well, usually you would be making a pull request to merge your own branch into a develop branch, but in this case, I think I set it up so that it would at least show some changes. And we have like description here, but also there are ways that you can discuss code. So let's actually show that right now. So right here we have an example of a pull request. So this is actually a game development project that I've previously worked on. And pretty much we have the title of the pull request, we have a number, pull request number 269, and we have a description of it right here. And we have different tabs, so you can see the files changed, you can see different checks to the code. You can see all of the commits here. And then you can see the conversation. So you can see that after I initially made the pull request, I was actually able to still make changes to the code. And the director of the project had a few notes for me and wanted a few changes for the code. So he requested some changes. I made those changes. So here's the commit from that. And then it was merged into our develop branch which is up here. All right, let's talk about what is a merge conflict. So a merge conflict is pretty much a conflict between incoming changes and your local changes that cannot be dealt with automatically. So pretty much usually Git is very good at merging different changes through files to sync your files with a remote repository, for example. But sometimes, let's say someone has made a change to a remote file that is the same file as yours, but Git was not able to merge them correctly. You'll get a merge conflict. And so in the bottom right here, you can see a visualized merge conflict from Visual Studio Code, where you have the options to accept the current change, which is your change, accept incoming change, which is the syncing change from the remote repository. You can accept both, and you can also do some actions to compare them as well. But you can see that the current change that you've made is writing green right here, while the incoming change, someone wrote white right here. And so pretty much what you have to do to be able to actually merge the branch is you need to resolve the merge conflict before you can finish the merge. All right, let's talk about the different types of merges. So a default merge, or a merge, pretty much merges individual commits to a branch and an additional merge commit. So in the bottom right here, you can see, let's say this is your develop branch or your main branch in pink or purple. And you can see your own branch that branches off of this one. And when you go to use the default merge, pretty much what it does is it puts your commits in between commits that other people have made. So in the timeline, you would see like their commit, your commit, their commit, your commit, for example. That would be in a timeline, an ordered timeline like that. We also have the option to squash and merge, which combines all commits into one commit and then merges. So we can see here, you have your main or develop branch, you have your own branch, and when you go to squash and merge, it squashes all of your changes into one commit and puts it at the front of the main or develop branch. And then we have a third option, which is rebase and merge. And so what this pretty much does is it creates duplicates of all of your changes so that it's able to put them in front of the main branch or your develop branch. And then just a note here, because it's creating duplicates, they'll have different be a different timeline pretty much. And then it pretty much rewrites the project history. But pretty much there is a golden rule of rebasing, which is to never use it on a public branch. And pretty much this is because when you're merging by the way, a public branch is a branch that multiple people are working on. So the public branch here would be in purple, for example, and your branch would be in red. And so if you were to use rebase and merge with the main branch here, or your develop branch, pretty much what it would do is, and if you were merging it into your branch, it would make a copy of all history, and then and then put it in front of your branch pretty much. And you do not want to do that because it causes a lot of issues. And so only time you'd want to use rebase and merge is if you want to put yours in front of the public branch. You do not want to put the public branch in front of yours. All right, let's talk about Git workflows. So many types of workflows exist depending on what type of project or the number of collaborators that are in your project. And so here's a basic workflow for a small project. So step number 1 would be to clone the repository from its remote source. So for example, you can create the repository on GitHub and then clone it to your local system. Or you can create the repository on your local system and push it up to GitHub. Secondly, you're going to be creating a new branch. You're going to be working on the code on that branch and making commits regularly so that you have a history that you can go back to in case you need to look at previous code changes. And then you're going to want to regularly sync your branch with your development branch, with your development branch. And this is to reduce the number of merge conflicts that you get. And regularly syncing with your main development branch is usually when you're on a team with collaborators. And then when you're done with a feature, you're going to be creating a pull request, which again is a request to merge your changes. You're going to have code reviewers assess the changes and make necessary changes and you're going to make the necessary changes to get the code accepted. And then finally, the code reviewer is going to merge the pull request. And optionally, you can delete the branch as well. And then you would repeat from step 2, which is create a new branch. So I know I've been saying main or development branch a lot, but the recommended method, or like the recommended way to have your project structured is to have a main branch as your production ready branch, and then have a development branch where it can be used to quickly sync new code with collaborators. And in this way, the main branch, when people go to clone your repository, will always be up to date with working code, whereas the development branch may have some experimental code, and even though it's tested code, it could still have bugs that have not been found. All right, and then this is so we have 2 diagrams here which pretty much have the exact same workflow, but these workflows are for medium or large scale projects. So pretty much what you would do is you would have here. So we have our main branch, right? And so this is not the branch that you're going to be working on. You're going to be working on your own branches. But the branch that you're going to be syncing to regularly is going to be your development branch. See how there's a lot of commits here from different people. And then from the development branch, you're going to actually branch off into, each person is going to branch off into their own branches to work on features. And eventually merge back into the development branch so that the development branch is up to date with people's code changes. Once the code's stable enough to be released, you would create a release branch. And in this release branch, you wouldn't be adding a bunch of new code. It would be only bug fixes that you'd be looking for and fixing. And once the code is stable enough, it would be merged to the main branch, which again is the branch for production code only. So down here, yeah, you can see everything. Main branch is for production code only. The develop branch is for development code. Feature branches are created from the development branch. Hotfix branches are created from the main branch. So for example, if there's a bug in the main branch, and you want to make a bug fix for it, if it's a small fix, it's called a hotfix. And pretty much what that entails is you branch off from the main branch, fix the bug, and then it'd be merged back into the main branch, but also merged to the development branch so that people have up-to-date code from that hotfix as well. And then the release branches are created from the development branch for releases. And then on the right here, this is pretty sure it's the exact same diagram. Just vertical instead. All right, so let's talk about best practices for Git. So make sure to not merge directly to the main branch or directly to the development branch when contributing to a team project, and make sure it's only done through pull requests so that people can discuss code changes. And protections on GitHub can actually be turned on to disallow direct merges to branches so that you don't have to worry about people merging directly to your main or development branch. And then again, you want to have main as the most stable branch that contains only production-ready code. Make sure to also use good naming conventions for branches, commits, and pull requests. So some examples for branch names would be feature / motor controller driver. And we have you'll see the pattern here. You pretty much have the thing that describes what it's going to be. So feature, or something that's experimental, or a test, or a bug fix, and then /, and then the actual name of your branch. And pretty much in a lot of the Git GUIs, with this feature /, it'll actually create a folder called like a visualized folder called feature, and you'll have all your branches under feature, for example. So yeah, for another example, bug fix / camera quality fixes, experimental / gamepad controller quality of life, test / example branch. And then some descriptions for commits. Some examples are fixed gamepad recognition issue, added temporary GUI, optimized search algorithm, updated motor configuration, removed redundant code, added comments. You want it to be short but descriptive of what types of changes you've made. And then also make sure to delete old branches to keep the repository clean. I've seen some repositories that have many branches that have code that is very old and does not need to be there anymore. And so if it's newer code, you may want to keep that so that it's easy to find old code. But if it's very old code, then you can go ahead and delete those branches. And then also make sure to commit regularly to your branch when you're working on a feature, and sync your branch regularly with the develop branch to reduce merge conflicts. And that's it. Thank you.